This is Garrett Fry. I am a concept artist, matte painter, and environment artist for over 15 years, and I've also worked as a director of learning and development for several studios ranging from VFX, animation, commercials, and games. I'm going to be demonstrating a workflow that's an alternative to a lot of the AI videos that you see online that make really big claims, but in reality, they're just simple text prompt to video generation that anyone with a keyboard can create. I'm going to be showing you a workflow that's going to give you total creative control over the AI to create all the control images that you're going to need to guide AI video generation. We're going to start with creating a character, training a LoRA, building an environment, and creating a layout. In the end, we're going to have final start and end frames, and we're also going to have an image sequence of control canny and depth images for our shot. For this workflow, I am using a lot of local AI diffusion models, which means I'm loading the AI models directly into the RAM of my video card and using that for AI image diffusion. While I have a pretty hefty local setup, you can do everything that I'm doing in this workflow in the cloud by using Comfy Cloud or renting a GPU online. So there's nothing that's stopping you from mimicking this workflow for your own creative project. So saying that, let's get started. I just wanted to quickly go over my system setup that I'm using for this project. On the left-hand side are the specifications for my primary workstation. I am running Windows 11, an AMD Ryzen 9 12-core processor, 64 gigs of RAM, and an NVIDIA RTX 5090 with 32 gigs of VRAM. On the right side, I have a headless render node system that is running Rocky Linux, and it has the same specifications with the same exact RTX 5090 video card. This setup allows me to be able to train LoRa's on the render node while still working on my primary workstation, or just running Comfy UI server on the render node and accessing the interface from my primary workstation, which allows me to have Photoshop open and other applications running at the same time. Both are running AI models locally with a sync task so that the model directories are identical. I'm also running a Synology server and have symlinked several of the directories so the two workstations are working from the same directories. On my local server, I'm running Bookstack, which is an open source documentation platform where I have documented all of my workflows, including my starter scripts that I use for my Comfy UI templates. Now, I use several different applications in this project, and what ties them all together is an application called Prism. And it's a pipeline application that gives you the ability to store all of your project files and all their outputs and keeps it within its folder structure. And so if you know anything about Prism, then you know that it's broken down between shots and assets. Here you can see I have character, where I have concept, modeling, and identity. This section here for identity is all of the Comfy UI scripts that are used to build the LoRA pack. That's all of the images and the text documents. So you're going to see versions of Comfy UI files right here on the right-hand side. Now, Comfy UI is not a natively supported application inside of Prism, and so I created my own custom plugin to be able to get files from Comfy UI and into Prism and back again. So let me just quickly show you what that workflow looks like. If you go over here to one of these files and you right click, there is a menu here called Comfy UI, and you go over here and you say copy workflow to clipboard. Now if I go and open up Comfy UI and paste it, this is the file right here. And if I wanted to save this file and put it back into Prism, then I would go over here to the menu, and under extensions, there is a menu that I created called Prism, and you can copy this workflow JSON file as plain text. And then you go back into Prism and you say right here under Comfy UI, save new version from clipboard. And you can see that it's been saved right there. I also created a custom plugin for AI Toolkit because I wanted to keep track of the YAML files And to show you that, under LoRA training, you can see these YAML files stored here inside of the Prism pipeline. The workflow is very much the same. If you right-click on one of these versions and go to AI Toolkit, then you can copy the YAML file to your clipboard, and then you can paste it inside of AI Toolkit. You can also be inside of AI Toolkit and copy the YAML file that you've created inside of there, and you can save a new version, and then you can label it right there inside of Prism Pipeline. Now that we've covered the system setup, we can get to the actual project. I started this project by freehand sketching a robot design in Procreate on an iPad, and then I'm going to use this illustration as a control image in directing the AI to create a photoreal version of the robot. From there, I'm going to create a large data set of images and train the LoRA so the AI can recall this robot with a keyword. Then I'm going to create a rigged character and then use that rigged character to generate control images and guide our AI keyframes. Inside of Comfy UI, I've loaded my illustration of my character here, and I'm using a Flux 2 dev model so I can get a really nice photoreal look. Here is the prompt that I used, and I iterated on this quite a bit to get the result that I wanted. But after doing that, it was able to produce reliable looks that I was going for. And I ultimately went with this as the final design of the robot. So I selected this, and now I'm going to take this and move it to the next stage of creating a character sheet. To generate my character sheet, I utilized Nano Banana because it has a really good character lock from all different views. So I went ahead and loaded in my selection of my character from Flux, and I put in a prompt here. And you can see here that because this character was not created as a neutral pose in a front view or a side view, it was having a little bit of a hard time thinking of it in a symmetrical way, but it did need to be symmetrical, so I needed to force that here inside of the prompt. So after a couple of rolls, it's able to give me a pretty good output. And this is the final image here. It's pretty high resolution, and it was able to pack in a lot of really great detail of scratches and scuffs here within the robot, and I felt like that was a really good default neutral pose here, and that is our turnaround right there. So now that my character is locked, I want to start building out a data set of images that I can use to train the LoRA. And so the first thing I want to do is use this exact image of these characters in their different positions, but put them in different lighting conditions. That way I can ensure that the characters stay exactly the same. So I'm still using Nano Banana for this, and that is in my prompt to keep these characters exactly the same, but to put them into different lighting conditions. And so you can see some examples here of that. I'll later go through and cut these up into different images and use those as part of the data set. The next part of my data set is to get images of this character in drastically different positions so that the AI can see the range of motion of the robot. So utilizing again Nano Banana and my prompt here, and you can see that it's generating some pretty good images of the robot, some that are not as good as others. And again, I will cut these up and add them with descriptions into the data set. So the last part of my data set is the detailing of the robot. So I went through here also utilizing Nano Banana and generating a bunch of different prompts of the different close-up areas of the robot. And you can see it does a pretty good job keeping things consistent. Although there are some images that are not great that I'll just go through and filter those out and not include those in the final data set. So now that I have a pretty good set of images for training, I need the companion text files that's going to describe each of these images. So to do that, I've created a workflow inside of Comfy UI to automate this. And at the beginning here, I've specified the keyword for the LoRA training. It's robot 1A. And I have a join strings here that's going to add this keyword at the beginning of each of our text files. I have a batch load that's happening right here that's going to feed into this Quen image to text generator, and it's going to generate out a text file for me there. I have several of these set up, and each of these are set up by the different types with different instructions. So I have some that are for different angles and the close-up version and the lighting conditions and the action poses. They all have their own instructions, and I have this set up so that when this one is completed, I have a execution controller to activate the next save node here. And so it's going to get through all of these and give us text files for each of our images. So here in AI Toolkit, I have all of the images that I generated and the text that goes along with them. I did need to go through and hand pick and make sure that each of the images were consistent and were good as a part of this data set. I also needed to go through and make sure that all of the text was descriptive and correct for these images. And you can see we've got different lighting conditions and poses and close-ups. I think there is about 130 of these images that I used in this training. Now that I've created everything that I need to train the LoRA, I can now move on to creating ControlNet images. I'm going to be pairing my text-based guidance of the LoRA with a ControlNet to give me more control over the images and the video generation. So to do this, I'm going to be utilizing some image to mesh models like Hunyan and Trellis to give me a basic mesh so that I can turn that into a rigged character. So here's the 3D mesh that I assembled from several image to mesh models that I used that I feel like best described the character. So I went through and I made sure that the profile and the front views really matched the artwork that was used to train the LoRA so that I would get a really tight match on the ControlNet and the trained LoRA. This is a fully rigged character here, as you can see, with inverse kinematics and joints in all of the right places so that this can be animated and posed. So this 3D model is going to be used to create the control nets. That would be the depth, the canny, and the open pose. You can see here that I have gone through and also created an open pose skeleton for this character so that when I pose it, I can get the depth and canny and also the open pose all at the same time. So now that I have everything done with the character, it's time to move on to the environment. And so I went to ChatGPT because I wanted to leverage the persistent memory that these chat models have so I can start iterating on some ideas. And I wanted to develop it in stages. So the first part is I wanted these striped, wonky, kind of wavy buildings. And so I started with this image and drew some lines down it because I wanted some partitions and asked it to generate some things for me here. And then I went through and gave it a profile here and had it generate some of these from the ground view. And then I wanted to really muck it up. So I made it dirty and then had these really dystopian kind of concepts created. And based off of this, I had it isolate some buildings for me and also distress those buildings. So I actually took these images right here, downloaded them, and put them into a Comfy UI workflow for Trellis and generated some basic mesh that I used in the laying out of my scene for my environment. So let's just jump over to Blender and I'll show you how that all came together. Here are the buildings that I created in Comfy UI with Trellis. You can see there's a lot of variation of these types of buildings in the level of destruction and vegetation and style and shape. And so this is going to give me everything I need to lay out our scene. I think that they are at the right level of detail. Really, they're just going to be used to generate depth and canny information, so they don't need to be really that great of models. They just kind of need to give the feeling of this kind of alien post-apocalyptic environment. So over here, I have also created several tiles of the ground with different rocks and formations and things like that that I'm going to use to put in the foreground and in the background to add some variation. So this is really kind of the foundation of the environment between the buildings and the ground. So the next thing that I'm going to do is to just generate props for this environment that I can kind of just put in different places, especially around the character. So let's go to that point. So in order to generate these props in mass and really quickly, I have NVIDIA's blueprint for the 3D object generator. So this is something that you install inside of a Docker container. It has Trellis. It also has Llama to be able to take your text and make it into 3D objects. So right here we have a web page that is hosted locally here within the Docker container, and I'm going to go ahead and put in here a description of post-apocalyptic dystopian destroyed street with debris. So I'm going to press play on this. It's going to go through and actually generate a bunch of prompts, and then it's going to go through and answer those prompts and create for us a bunch of objects. All right, it's gone through and it's taken our description and created for us a bunch of images that we can turn into 3D objects. So you can go through and select specific ones that you want to create. You can also regenerate based on a text prompt if you click on this pencil icon. But I've gone through and clicked on this button here that converts all to 3D. You can now go through and export all of these objects into a scene name right there, and it's going to dump all of those objects into a folder that you can pick up in Blender. So let me just show you that. So here inside of Blender, there is an asset importer tab that is part of these tools that came in with this workflow. And so I'm going to select on our folder that we just created and all of the assets. I'm going to say accept, and then I'm going to import those assets. And you can see that they're being dropped into your scene here. And you can see all of those assets there all lined up. So you can pick through, select which ones that you want to keep and which ones you want to just chuck. But you can see that it's a really fast way to create props for your environment, just to have some shapes and things that the depth and canny passes can pick up. So here is the environment laid out. You can see I have some buildings here, these ground tiles, and some props that I've generated and thrown in here. It doesn't look great from this point of view, but if we look from our camera, then you can see how all of this is coming together. It's going to create some really great depth and canny information for us to be able to create some nice images. You can see here that I have a robot that's on the ground that's kind of been destroyed. That's kind of part of the set. And then I have another character. So let me just show you that here. So here is our character here, and I'm going to show you what this looks like from one of the shot cameras. So this is the first shot camera, and if we play this through, then you can see that the character is coming down. He's reaching after this broken robot, and then looks up a little bit right there. Okay, so that's the first shot right there. And the second shot is from a lower angle right here. And let me turn this on right there. And you can see that there's this rocket here in the back, and the robot looks up over its shoulder and looks towards the building, kind of crouches, and we see some explosions on the building there. Okay, so that's the next shot right there. Okay, so from all of these angles, we're going to have all of our control render image sequences. That's going to guide the AI. We're going to have the trained LoRa's on these characters, and also I have a keyframes that I'm going to create that are going to be the start and end keyframes, and which is basically going to start from this view. I'm going to generate some images based on this view right here, and it's going to, this angle kind of encompasses everything that's seen within those two shots. And so I'm going to use this to create the shot keyframes, and this is going to be like our main control image. So I'm going to show you how I assembled this image here. So to create this one big oversized canvas of our environment that we're going to use to drive other keyframes, there's several steps in this process, and the first one is just to create a base image. And to do that, I'm actually using Flux 1 because I think that is a little more creative and tuned for what I want in this particular case. I also have some nice LoRa's that I'm going to be using to give me the look that I want. I have my two control images. I have a depth map here, and I also have a canny image, and I'm using both of those as a ControlNet, and that is going to generate our final image here. So I created maybe 30 different variations of this, and then I picked the very best one. And I'm going to show you what all of those look like at that step. So here are the images that I generated, and you can see that a lot of these have a really nice feel to them. I adjusted the settings and the prompt to give it some more or less creativity on what it did with the image. I did specify a time of day, but not a lighting direction. And so I left that open to see what would happen and see what looked good. And so you can see that it's done a pretty good job of all of that. You can see here that there are these shapes here that look a lot like the robot, and the robot was on the ground, and it's in the depth and canny control images, and that's starting to come through here. I did not train a Flux 1 model that I injected in here because I'm going to take care of that at a different step. What I just wanted to do is do that as a completely different process and just focus on the image generation of the background. So the one that I settled on was this image right here. It has a really nice halo on this building right here, and the sun comes across this building here, and that's going to be kind of our target when that missile hits the building. And so I wanted to be able to see the light on that building. But the foreground here is really rubbish, especially over on this side. And so I'm going to go through and do a foreground in paint of this and reconstruct this area. And then I'm going to go back through and I'm going to in paint do the robot there. To do the in painting, I'm going to be using Flux 2 because it has a much better method for handling in painting than Flux 1, and I'd like that higher level detail that new model offers. I'm using the Flux 2 Dev Fun ControlNet Union there as a ControlNet, and I'm using the Apply Flux to Fun ControlNet right there. So I have the image and I've masked this out to isolate that area. And I've also re-rendered the depth pass so that it is isolating just the foreground there. And it's because I wanted to maximize the values within that range so that I could really push the ControlNet to follow those shapes, because I really want that to be better aligned there. I don't want so much of the variation that it created in there. I don't want that to be as creative as what it was doing with the background. So I rolled the dice on this, about 30 different images. I'll show you what those look like. Here are the images of the inpaint on the foreground, and you can see that it's following that a lot better. And I did give it a prompt that I wanted it to be mostly rubble. You can still see the silhouette of our robot there that's showing up, and I haven't addressed that yet. I'm just looking for some nice rubble in the foreground. This is a sub-selection of the larger group that I generated. The one that I ultimately went with was this one right here. I feel like that had some really good shapes in it right there and went along with some of this other rubble on the side. And so the next step is to do the inpainting of the robot and get it put in there. For inpainting the robot on the ground, I am still using Flux 2 with the same ControlNet. I am adding to this workflow the LoRA that I trained on the robot, and you can see here that I'm using the keyword to call it out there, but I am also including some extra information on what I want the robot to be like as it's in the ground and partially dismantled. That's not actually what I trained the LoRA on. All the pictures of the LoRA that we've looked at has the robot standing and doing different actions, none of which are disassembled or in the ground or broken. And so I have to be quite specific about how I handle this to give the AI model the best chance of being able to recognize that as the robot and to generate the robot. So you can see down here is our original image, and I have a really tight mask around the robot. I am growing the mask there to be able to change some of the pixels around the robot, like the shadowing and different things like that, or the interaction between the robot and the ground. And you can see here, I have a depth map of just the robot, and I have taken a occlusion pass and I've laid that very lightly over top to try to give it as much depth information as I possibly could. And then, of course, I have the canny image right there. So I rolled the dice on this about 30 different times to see what it would give me. And so I'm going to show you what that looks like. So here are the image generations of the robot, and you can see it's coming through in a lot of ways, but in some ways it's really missing here. And you can see that here, and this is even a sub-selection of all of the renders. And so there were some that were even worse than this. And so some of them don't really work at all, and some of them are pretty good, and some of them are really off. And so you can see that it's not really getting a very good character lock. There's just, you know, the LoRA wasn't trained on this. There's just not enough information in the control images to be able to generate this, and that was expected. And so taking all of these images, I went through and I picked the very best arm or leg or head and composited them together inside of Photoshop. So here inside of Photoshop, you can see that I have a pretty complete robot as it is broken. There is some variation between this robot and the robot that we have our concept images of. And that's okay, because we're just saying that this is a destroyed robot. Maybe it's a different model or a different style, or maybe it's older or something like that. But it does need to be recognizable as the same style of robot, or belong to the same family. So you can see here that I have different areas that I have assembled this robot. That's where I started from, and you can see the areas that I've built up here like that. I did some reconstruction of this arm using the depth map, actually, or the occlusion map, to give some strengthen the definition of that arm and things like that. So that's a pretty good result of that. And let's go ahead. And now that we have our complete image here of our background and our foreground and our broken robot there, then I'm going to take this to the next level and do another detail pass using Flux 2 and also an upscale pass on this. On this image here, I'm going to ultimately want to do a upscale and get a lot of detail in there. As you can see, this is pretty low resolution. If you look in the back here, you can see there's a lot of mushy detail in the back. And that was all created with Flux 1. So with Flux 2, I'm going to run this through a refinement pass before we do a big upscale on it. And so if you take a look here, we're doing a Flux 2 here with a prompt, and we're just feeding this in as a reference latent and giving it a flux guidance on that. And for the prompt here, I'm telling it that it needs to preserve the original image, but fix any problems like obvious artifacts, non-logical errors, and I want you to create some detail in the image. So the Flux 2 model is really good at following prompts. And so I've also created some information about the robot because I want the robot to have more dings and scratches and dusty. I want it to be a little more a part of the environment there. So it's going to follow those two. I rolled the dice on this maybe 30 times again, and we'll take a look at that. In addition to that, I have the upscale that I've done. And so this takes a little bit of time, and so you can see that I batch did the upscale here on all of these images, and it's going into a ultimate SD upscale node right here, and it's using the Flux model here, and this is the upscale model that I'm using here to drive that. This node is chopping up the image and assembling it again and giving me a higher resolution image. So I'm going to show you the result of the detail pass and then the upscale here as well. All right, so these images have gone through a refinement pass and an upscale, so they're twice the resolution. So you can see there's a lot more detail in these images here, and we got some scuff and dents and things in the robot. Some of these are better than others. You can see that there's a subtle tone shift that's happening in some of these images as a result of the AI regenerating the image. And you can see some of these are pretty good. So this one here is the one that I selected to move forward with. It has some messy details here that have enhanced the robot, and it's maintained the right color that I want here, and it's added detail in throughout the image. And so that's a pretty good image to start with when we're talking about creating that one big overscanned image that we're going to use as reference for all of our other keyframes for our shots. All right, so now that we have our large overscan canvas where all the action is going to be happening, let's focus now on creating our start and end frames for our shot. So here in this Comfy UI workflow, I have here a cropped in version of our upscaled canvas that's going to be this view. And this view is not going to, the perspective is not going to be exactly correct for our shot camera. And you can see I have in 3D, I have two control images that I've generated of just the background. I'm not worried about the robot right now. and you can see that it doesn't line up exactly, and that's expected, right? Because I'm using this as a style control, and then I'm using these as position control. So I have here using Flux 2, and it is using the Minstrel language model, which does help a lot with being able to interpret prompts. And so here I'm telling it to use the canny image and the depth image to control the composition, but to keep everything else the same. And so that is going to generate for me a background image, and it's not super far off. The position of the camera just slightly changes, and so some things will change, but not a lot. And between those two things, it's enough for the AI to infer what the changes would be. The next step here is positioning the robot. So I have the background. I've gone through the process of selecting the background image from multiple generations and doing an upscale on it. So we have a 1920 by 1080 image for here. And I have a very tight mask of our robot along with a couple of control images. This is the start frame. And I have in here my LoRA that I've trained, and that is going to fill in the character. Even though we have the character trained inside the LoRA, I'm still providing it very specific direction of how to place the character inside of the environment. So once that's been generated, you can see here that there's some like really light detailing on the forearm and on the head and the helmet and things like that. So I had a choice of what I could do with that. I could further train the AI on the markings of the robot. And what you would want to do for that is a hierarchical labeling so that you could specify and say, this is the right arm, this is the marking on the right arm, and then you can add that as additional keywords inside of your prompts to help the AI know that this is the marking that you've been trained on for the right arm and this is what it needs to be. However, for this particular set of shots, the choice that I went with is just an in-painting process. So from the data set that I have, I just went through and did an in-painting process for the start and end frames. So I can select this area, this masked area right here, and it's going to go through and chop that area out of the larger image, and it's going to fill that in based on a reference image that I have here from the data set, and then that is going to put it back on top of that image there. And so after all of that and some further just refinements in Photoshop, so I wanted to go through and I wanted to tweak some of the lighting and the coloring and make sure that the color intensity and the specular highlight was correct, and make sure the in-painting of the shoulder, on the helmet, on the arm was all correct. And so once all the, and that's actually where I composited all the in-painting was in Photoshop. I previewed that in Comfy UI, but it all came together inside of Photoshop here, and this is the start frame. So here is the end frame, and I just went through the same exact process of creating the background and the foreground. You can see that they're separated here in Photoshop, and this is where I've done all of my final tweaking of this image and making sure the lighting and the detailing and the in-painting has all been done correctly, and there's continuity between the two frames, my start and end frame. I can also show you here that because I have a full layout of this sequence with multiple shots, I have here some control images that I've rendered on every frame. So this is the depth, and this is the canny here. This is just of the background. So I have the ability to render these control images on every frame, provide a start and end frame, and now I have a lot of information that I can provide a video model. I think that you can see that this is really far from a text to video method for generating images and videos. Text to video models are essentially a random roll, and it gives you very little control over the final image. In this workflow, I'm making creative decisions throughout the whole process. It's my creative vision that's coming through. It's just that I'm using a different set of tools than I have on other projects. I hope that this gives you an overview of this process and helps you feel that as an artist that you're empowered to start working with these AI tools in creative ways and create your own workflows.